about chemistry. Today we're going to talk about Lewis dot structures. So first, some information about Lewis dot structures. Lewis dot structures are a way of drawing to keep track of just the valence electrons. Remember, only valence electrons, outer energy level electrons, and we're only talking about covalent compounds today. We're going to use dots to represent, again, only the valence electrons. Think of it like this. Electrons can go on the four sides of the symbol. And you would put the electrons singly at first and then pair them up. Kind of like when we learned about drawing electron configurations. The electrons will go by themselves first before they get apart. The rest of the atom you would just represent with the symbol. So when I'm talking about the rest of the atom, I'm really just referring to the nucleus and then the inner electrons. We don't need to worry about them because they're not really involved in forming bonds. A bond is formed by sharing two electrons, and that would be in between the atoms. So you can see here for HBr, those two electrons in the middle are what are forming the bonds. So a couple of things to think about, some terms to know about. A single bond is when just two electrons are shared in between the atoms. You can also have a double bond we'll talk about, and that's when you share two pairs of electrons, which would be 4 electrons total. Or you can have a triple bond where they actually share 6 electrons, which would be 3 pairs, again in between the two atoms. And then there's some diagrams over here. You can see a single bond, double bond, and a triple bond, how that would be represented. Also, you have to think about the lone pair electrons. The lone pairs would be if there is a pair of electrons on the inside atom or on any of the outside atoms that is not involved in the bond. So a pair of electrons that's just hanging out not on a bond. When we are drawing Lewis dot structures, we have to follow the octet rule. Remember, we've talked about it a lot of times. The octet rule is when we talk about 8 is great. And that's that when you form bonds, each atom needs to have 8 electrons around it to be stable. Remember, stable means happy. There's some exceptions to that. Hydrogen, for example, is happy with just 2 electrons. Also, boron can be okay with just 6. And then some really big atoms might exceed the octet rule. They can have more than 8. We won't really deal with those, though, in this class. So I have some examples there. Carbon tetrachloride down here. Okay, each atom around it has 8 electrons, and so it's happy. And then SiH4 also shows how the octet rule makes it happy. Okay, so let's talk a little bit of how to actually draw a Lewis structure. So these would be the steps that you want to make sure you follow. So first up, you total up the number of valence electrons. Remember, we're only working with valence electrons. When you put the structure together, generally the first element listed in the formula goes in the middle. The notable example would be hydrogen, like for water, H2O. Hydrogen always must be on the outside. You're going to put a single bond, first of all, for each connection, so to connect the atoms together. Distribute the extra electrons that are left over outside so that they fulfill the octet rule. If you still have extra electrons, put them on the central atom. And then, if necessary, you might need to go back and redistribute electrons and make a double or triple bond. And again, when you're all done, you always want to make sure, double check that everyone is following the octet rule and that everyone is happy. Just a little reminder to you, when we're figuring out numbers of valence electrons, remember you always want to count valence electrons based on the group that the atom is in. So group 1 has 1, group 2, 2, skip these guys, we won't count valence electrons for them. 3, 4, 5, 6, 7, and 8. So let's look at some examples. So our first example is draw the Lewis structure for H2O, good old water. So again, first step, total number of electrons. So you count up the total number. Oxygen, where it is on the periodic table, it has 6. Each hydrogen has 1, but there's 2 of them, right? So it's times 2. So 1 times 2 plus 6, so you have 8 total. So you're going to put oxygen in the middle. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. And then you have to put your hydrogens. So you're going to make a connection to hydrogen. Here's a connection, hydrogen, and then here's another connection, hydrogen. You've connected everyone, and you have no more electrons left over, because you can count up. 1, 2, 3, 4, Each bond, remember, counts for 2, so this would be 5, 6, and this bond would be 7, 8. Everybody's happy. Perfect Lewis structure. Okay, next example, number 2 here. So we're going to draw the Lewis structure for NF3. So first thing you do is look up on the periodic table, number of valence electrons. N has 5. F, each F has 7. So that would be 7 times 3. So you're working with a total of 26 electrons for this one. Again, you want to follow that rule that I said. Generally, the middle atom is listed first. So you put N in the middle. You put N's 5 electrons around it. It's kind of a good way to start. 4, 5. Okay? You're going to connect 3 fluorines, right? So make a connection here, and F. Make a connection here, and F. Make a connection here. Alright, so far we've used that 1, 2, 3, 4, 5, 6, 7, 8. Now put the rest of our electrons. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. You go back, everyone follows the octet rule, it's all good. Everyone's got 8. Nitrogen's got 2, 4, 6, 8. Very good. Okay, let's try this one. Draw the Lewis structure for CCl4. So carbon has 4 valence electrons. Chlorine, or halogens, has 7, and it's 7 times 4. Then you're going to total those up, and you get a total of 32 electrons used. Carbon goes in the middle, which is listed first. Carbon has 4. 1, 2, 3, 4. You're going to make some bonds. You have 4 chlorines still all around it. Cl, 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 Cl. One thing you want to remember is you also would like to look for things that are nice and symmetrical. That makes atoms happy too. So you have your 2, 4, 6, 8 electrons used currently. Put the rest on there. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Looking good. You just have all the electrons and go back and double check. Everyone follows the octet rule, so another good one. Okay, so now we're going to try out SO2. So SO2, again, you look up the valence electrons. S has 6, and each oxygen has 6, so that would be 12 total, because we have 2 oxygens. So 6 plus 12 would be 18 electrons, which you're going to be working with. Okay, so again, you're going to put S in the middle, and you can say, okay, we have 6. 1, 2, 3, 4, 5, 6. Okay, looks good. Now make a connection to O, so we have one connection here, and another connection here. Alright, so far we've used that 1, 2, 3, 4, 5, 6, 7, 8 electrons. We go 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, problem. Problem is we're not following the octet rule for everything right now. So this is where we go back to that step where we had earlier where it said if it doesn't follow the octet rule, you might have to redistribute the electrons and make a double or maybe a triple bond. So you see here that you have this pair of electrons just hanging out here, and this oxygen is kind of lacking a little bit. So what we can do is we can take this pair of electrons and just redistribute it, which means move it around. We'll take it from there, and we'll put it right here and make it into a double bond. So now we have here, this S and O are having a double bond, and the double bond is 4 electrons total. So this S right now would have 2 in that lone pair, 4, if we count this, 6 for the first part of the bond, and 8 for the second part of that bond. So sulfur now will follow the octet rule. Super. And then each oxygen also. This one down here in the bottom, 2, 4, and then 6, 8. oxygen up here. 1, 2, 3, 4, 5, 6, and then 7, 8. So now we are following the octet rule, and we have a double bond here. So sulfur double bonded to oxygen, single bond. You might be wondering, does it matter where you put the double bonded oxygen? No. You could have it anywhere, top or either side or bottom. It's good. Okay, another example. Now we are going to draw a Lewis structure for N2. N2 is nitrogen, the gas that you're breathing in the majority of the time. That's what most of our atmosphere is made of. All right, each N has 5, so we have 5 times 2, which is 10 electrons total that we're working with. We just have N2, so we're going to put an N in the middle next to an N, right? So we'll just put our N side by side. We'll take 2 electrons to make a bond. We'll say 3, 4, 5, 6, 7, 8, 9, 10 maybe. Okay, so then you want to check for the octet rule. This one right here is great, but this one is not. Okay, so we don't want that. So what we're going to do is go back and follow that rule of redistribute the electrons. So we'll take this pair of electrons up here perhaps, and we will take them and make another bond. So now we have a double bond. Okay? So now we still are not following the octet rule. Now this guy is happy because he's got 1, 2, 3, 4, 5, 6, 7, 8. But the one on the left, 1, 2, 3, 4, 5, 6. Not good. Alright, so what we're going to do is continue our redistributing of the electrons. So take this other pair of electrons, bring it down to the right, and make a triple bond. We do that, now we have 8 around everyone, and now everyone's happy. You might be wondering, does it matter where that lone pair is? The lone pair? It doesn't matter if you put it on the top or the side or the bottom, as long as each nitrogen has one lone pair. And our nitrogen has a triple bond connecting them. I'm sure you're loving all these examples, and here is one last one. So example number 6. Draw the Lewis structure for NO3-. So this is actually the nitrate ion. Now notice this, it has a charge. Since it has a negative charge, that means you add 1 extra electron when you're counting up your total. So you look up N, N's got 5 electrons. Each oxygen has 6, so you have 6 times 3. And then, remember, since you have this ion, that means add 1 extra electron. So we're going to end up with a total of 24 electrons to put this structure together. So again, you're going to put nitrogen in the middle, because it's our central guy. First one listed. 4, 5, okay. Bond your O's to it. 1 O here, 1 O here, 1 O here. Okay, distribute. Right now we have 2, 4, 5, 6, 7, 8. Single bond by the way. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Problem, because this guy right here is not following the octet rule. So we just redistribute a pair of electrons from the central, from here, and we're going to make this a double bond right here. And now our nitrate ion is very happy. You show it's an ion by putting it in square brackets and put a negative outside. Thanks, guys.